What's up, everybody, in my AP Stats classes? So, got a couple people that were concerned about this first problem, so I thought I'd kind of help you out a little bit on it, especially since, depending when I'm going to see you next. So, anyway, dealt with Frank's iPhone and has thousands and thousands of songs on it, but 22%, supposedly 22% of songs are rock and roll music. And he wants to take samples of size 50 out of his database. And we want to determine, what would a sampling proportion look like, right? Because the idea of a sampling proportion is, looking at many possible p-hats, right? And the one thing that samples are going to do really, really well is that they're going to vary. So a sampling distribution shows what all possible sample proportions p-hats could look like if taken from Frank's iPhone, looking at the proportion of songs that are rock and roll music. So we build that sampling distribution without having to look at any samples. So part A says, what's the center? Well, that is the mean of all the p-hats that we haven't even actually looked at yet, which is crazy. So anyway, we know that the mean of all the p-hats is going to be the truth in the center, 0.22, as long as the samples are all bias-free and completely random. The second part, or part B, wants us to look for the standard deviation of that sampling distribution, because the one thing we know for sure is that those samples are definitely going to vary. So pretty easy formula here for the standard deviation of the sampling distribution. We're just going to take a giant square root. So we're going to divide it by or not divide it by, oh my gosh, I'm so sorry. We're going to take a square root inside that square root. We're going to take P, 0.22, times the other side of P, which would be the 78% of songs that are not rock and roll music, and divide that by our sample size of 50, and we get a standard deviation of 0.0586. Now, that is only true, that form is only usable, if we can assume that 50 songs is under 10% of the population to assume independence. Remember, we got to have independence, and we are safe to assume, it did say in the problem that he has several thousand songs, so 50 is assumed. We're crossing our fingers. We don't have to cross our fingers, but we should hope that we're under 10% of the population. Okay, great. The last thing is that the model should be normal, and I have that drawn here. I have a beautifully drawn normal model. I use the computer. I didn't draw it myself. But listen, the rule says you're only going to be normal if you're big enough. That means you have more than 10 successes and more than 10 failures within your sample. So I actually do have to check this real quick. So 50 songs in my sample, 22% of them are supposed to be rock and roll. Whew! 11 cuts it close, but as long as it's 10 or larger, you're fine. And then what about the 78% of songs that are not going to be rock and roll music? That would be the other 39 songs. Both of those numbers have to be 10 or larger, so we're good to go. All right, then I drew the picture. Don't know if it actually asked you to draw it or not, but whatever. I thought it'd be nice to see it. 0.22 is in the middle. I went up one standard deviation, up another, down one. So again, these are z-scores, right? So I went up one, I went up two, I went up three. Z-scores are how many standard deviations you are from the mean. Okay, now we're good to go. Now here's the question D. It says, what's the probability that a sample proportion, what's the probability that one of these p-hats is within 3% of 22? Now, within 3% would be anywhere from 19% or 0.19 to 25% within, up or down. So 0.25. So anywhere within 0.19 and 0.25. So if I'm looking at my picture that I have drawn, 0.19 is going to be, somewhere right around here, and 0.25 is going to be somewhere right around here. So I want to find the probability that I'm going to be in between there. And again, to do probability with a normal model, I need normal CDF, which means I need z-scores. So I'm first going to find the z-score of 19% by subtracting the mean, 22%. Now I say percent, but I got to use the decimal, 0.22. And I'm going to divide by the 0.0586. Now when I do that division, I get negative 0.5119 is the z-score. And I think that's, roughly where I put my line, right? Here's negative 1. Remember, the mean has a z-score of 0, so negative 0.5119. I think I'm pretty good there. And then what about the 25%? So I'm going to find the z-score for 25%. So 0.25 minus 0.22 divided by the 0.0586. And lo and behold, that equals positive 0.5119. Well, that makes sense. It's symmetric, right? So if I go down 3%, I should have the same z-score as up 3%. And again, that's roughly where I put here. So now what I want to find is the probability that a sample is within that, which means between 19% and 25%. And that is, of course, equivalent to a z-score being in between 0.5119. You may remember doing this on our previous sections about the normal model. And to actually get that answer, I'm going to go to my normal CDF on my calculator. And I'm going to grab normal CDF, and I'm going to look in between the z-scores of negative 0.5119 and positive 0.5119. And this would be the proportion or probability or percent of samples that are within that range. And, I typed something in wrong. Oh, I used a negative instead of a minus sign. So change that to a minus sign. There we go. Okay, 0.3913. So 0.3913. So there's about a 39% probability that any random p hat I grab is going to fall in that range of 19% to 25%. Okay, so hopefully that makes a lot of sense, right? And the picture allows us to see that. Now, the final question E says, all right, so, what's the probability that a sample comes back greater than 44%? So what is the probability that one of these p hats, again, remember, sampling distributions are filled with many of them. What's the probability that one of them is greater than 44%? So again, I'm trying to find the probability that one of my sample proportions is greater than 44%. And 44% would be, whoa, holy crap. 44% would be somewhere way up here. That's really rare. That's highly unlikely. It's really, really high. But of course, to get my answer, I do need to get a z-score. So I need to find out what the z-score for 44% is. So I'm going to go to my calculator to do that math. 0.44 minus 0.22. 22% is the mean in the middle, right? Divide that by the standard deviation of 0.0586. And I get 3.754. 3.754. And that confirms, that is definitely more than 3 standard deviations above the mean. I mean, 44% is way up here. So now to find the probability that I am officially a sample more than that, I am going to go and grab normal CDF here. I'm going to start at that z-score of 3.754. I'm going to go all the way up to 99. That 99 is acting like my infinity. And I get, oh my gosh, make sure you understand that e to the negative 5 means I got to move the decimal 5 times to the left, which produces 4 zeros. So 0.000087. 0.000087. So highly unlikely that a sample like that happens. Now, there was a follow-up question that says, okay, would this be surprising? Absolutely. Samples should not come that high. And if it did, what would it mean? Well, it would mean that something's going on, right? Remember we talked about when something crazy, unlikely happens, something's got to be going on. So, I don't know. Maybe the answer is that Frank has been changing his music preferences over the last year, and he's been adding songs, and it just so happens that he has been starting to favor more and more rock and roll songs. So the truth is that, well, the actual proportion of songs that are rock and roll is more than he thought it was. Like maybe it was 22% a year ago, but after increasing the number of songs on his iPad or iPhone that are rock and roll, it's actually higher. So I always think about hypotheses. So maybe the hypothesis that Frank was thinking was, hypothesis, like a scientific question. I wonder if more than 22% of songs on my iPhone are rock and roll. I've noticed I've been adding some more rock and roll songs. I wonder if I've actually risen the proportion of songs that are rock and roll. Well, if a sample came back 44% or more, I would say, yeah, you probably have some good evidence to support that claim, Frank, because if it was 22%, like you previously thought it was, 44% or higher would be very, very weird. That should not happen. Now, another rationale that a lot of kids want to go with is, oh, he lied. He lied. It wasn't a random sample. He was purposely looking for rock and roll songs. He was being biased. Well, hold on a minute. Remember, we already kind of mentioned with one of our conditions earlier that it was not a biased sample. It was random. So that's why the only logical explanation besides saying he cheated, which is what some kids want to say, is that no, maybe he has just slowly changed the proportion of songs that are rock and roll, and his hypothesis is correct that it's now higher. All right, but hopefully you had no problem building the model, but now hopefully I've helped explain a little bit more detail how to actually find these probabilities. And again, the key is it's normal. If it wasn't normal, I couldn't find any probabilities. So that's why we love the normal model. All right, hopefully that helped. Sorry if it was a little bit of a longer video, but I wanted to make sure I was really clear.